lesson that you learn about the properties of the axiomatic system. It also helps you understand the use of models to verify whether the axioms possess properties such as consistency, independence, and completeness. As you go through this lesson, you need to take note of the following questions. So, what is a consistent axiom, independent axiom, and complete axiom? Okay, so there are three significant concepts associated with any axiomatic system. So these are consistency, independence, and completeness. Okay, so let's have consistency. So an axiomatic system is said to be consistent if there do not exist in the system any two axioms, any two theorem, or any two theorems that contradict each other. Ulitin ko, if there do not exist in the system any two axioms, do not exist any axiom and theorem, or any two theorems that contradict each other. Okay, so equivalently, an axiomatic system is inconsistent if it implies a contradiction, that is, if it is possible to prove in it that some statement is both true and false. So masasabi natin that the system is consistent kapag walang dalawang axioms na magkakontra sa isa't isa, walang axiom or theorem na contradicting, or walang dalawang theorems na contradicting. Masasabi din natin na inconsistent yung isang system kapag posible na ma-prove natin na yung statement ay pwedeng true, pwedeng false. So let's have tests for consistency. If there exists a model for a set of axioms, the set of axioms is consistent. So to establish the absolute consistency of a set of axioms, you need to produce a concrete model. So let's have example number 1. So consider the following axiom sets for committee. So for axiom 1, each committee is a set of 3 members. Bawat komite ay naglalaman ng 3 miyembro. Axiom 2, each member is on exactly 2 committees. So ang isang miyembro pwede lang maging member on exactly 2 committees. Axiom 3, no 2 members may be together on more than 1 committee. Walang dalawang miyembro ang pwedeng magkasama sa higit isang committee. Axiom 4, there is at least 1 committee. So since the model of the set of axioms for committee exists, then it is consistent. Furthermore, the interpretation used in axiomatic system is adapted from real world, such as names of people which serve as model, then the set of axioms has an absolute consistency. Okay, so ito yung example natin a while ago. So concrete yung model because we use real names of persons. Tama? Okay, example number 2, show the following axiomatic system is inconsistent. So any one of the axioms can be proven false using the other axioms. Axiom number 1, there are exactly 2 boys. Axiom number 2, there are exactly 3 girls. Each boy likes exactly 2 girls and no 2 boys like the same girl. So let's have the model. Okay, so yung ating boys, pwede natin siya i-represent as B1 and B2. Yung girls natin, we would use G1, G2, and G3 as representation. Dito tayo sa ating model for axiom number 3. Okay, so boy 1 and boy 2 likes girl 1 and girl 2. Do they like the same girl here? Yes. So boy 1 and boy 2, that's girl 1 and girl 3. Si boy 1 and boy 2 gusto niya si girl 1 and girl 3. Si boy 1 and boy 2 gusto si girl 2 and girl 3. So check natin kung na-satisfy natin or hindi yung mga axioms. Sabi dyan, there are exactly 2 boys. Tama, si boy 1 at boy 2. There are exactly 2 girls, sabi ng axiom 2. So, meron si girl 1, girl 2, girl 3. Sabi ng axiom 3, each boy likes exactly 2 girls. So, meron tayong tatlong paraan para may pakita na each boy likes 2 girls. Pwedeng si boy 1 at boy 2, gusto si girl 1 and girl 2. Pwedeng si boy 1 and boy 2, gusto si girl 1 and girl 3. At pwedeng si boy 1 and boy 2, gusto si girl 2 at girl 3. Pero sabi ng axiom number 4 natin, no two boys like the same girl. So, itong dalawang boys natin, parehas na gusto si girl 1 and girl 2, which means that the axiom number 4 is not satisfied. So, we have already shown that the axiomatic system is inconsistent. Example number 3. Let's consider the set of axioms. So, undefined terms natin dito are point, line, and on. So, axiom number 1, there exist exactly 4 points. Axiom number 2, 2 distinct points are on exactly 1 line. And axiom number 3, each line is on exactly 2 points. Okay, so note that the construction of any model for the given set of axioms must begin with the objects known to exist. So, axiom number 1, tingin sa axiom number 1, it explicitly guarantees the existence of exactly 4 points. So, nabanggit dito, may kasiguraduhan na meron talagang exactly 4 points. However, axiom number 2 and axiom number 3 do not explicitly ensure the existence of lines. So, wala diyang nasabi na meron talagang lines, but it mentioned in each axiom. Walang sinabi dyan na nag-guarantee na meron talagang line, pero mayroon siyang na-mention na line. Yan, line. Hence, we will begin with the 4 points since these are the objects known to exist. Start tayo dito sa 4 points kasi yan yung sigurado na meron talaga. Exactly 4 points, sabi ng axiom 1. So, ang interpretation natin, points can be interpreted as letters A, B, C, D, or dots. While lines can be interpreted as columns of letters or segments. Okay, so let's have verification models. For model for axiom 1, okay, undefined terms natin, points, lines, on. Ang interpretation natin for points, letters A, B, C, D. Interpretation for lines, columns of letters given below. So ito, column for these letters, column, 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 and column. So on contains or is contained in. So show that the given set of axioms are satisfied. Ibig sabihin niyan, ipapakita natin na yung bawat axiom is a true statement. So axiom number 1 states that there is exactly 4 points. Since the number of letters is 4, ito A, B, C, D, then the axiom is satisfied. Kasi nga yung point na-represent natin ng letters. So point A, point B, point C, point D. Axiom 2 states that 2 distinct points are on exactly 1 line. So since 2 points contain in exactly 1 segment based on figure 1, then the axiom is satisfied. Tingin tayo sa figure 1 muna tayo. Punta tayo sa figure 1. Okay, so sabi ng axiom 2, 2 distinct points are on exactly 1 line. Okay, for example, ito point and another point. So 2 points are on exactly 1 line or 1 segment. So point 1, the segment connecting point 1 and point 3, okay, it contains 2 points. The segment connecting point 3 and point 4, okay, 2 points in 1 line. The segment connecting points 2 and 3, okay, segment connecting point 2 and point 4, segment connecting points 1 and 2. So, ibig sabihin yan, since 2 points contain in exactly 1 segment, then the axiom is satisfied. Okay, dito tayo sa model for axiom number 2. Okay, so axiom 2 states that two distinct points are on exactly one line. Since 2 points contain in exactly one segment, based on figure 1, then the axiom is satisfied. So, yun na yung sabi natin ganyan. Oh, this is figure 1. Model for axiom 3. Axiom 3 states that each line is on exactly 2 points. Each line is exactly 2 points. Each line is on exactly 2 points. This implies that for every line, there is exactly 2 points. Based on figure 1, then the axiom is satisfied. O gaya ng sabi ko kanina, each line, kunwari itong line na to, each line is on exactly 2 points. Itong line na to has 2 points, point 1, point 3. Itong line na to, meron siyang 2 points, points 3 and 4. This line has points 2 and 3, 2 and 4, 1 and 2. So since each axiom is satisfied, then the set of axioms is consistent. Since each axiom is satisfied, then the set of axioms is consistent. Punta tayo sa second property of axiomatic system, which is independence. An axiomatic system is said to be independent if it cannot be logically deduced from the other axioms in the system. So in other words, each axiom in the system is independent to one another. That means, ang isang axiom ay walang kinalaman sa isa pang axiom na nasa system. So tayo sa test for independence. To show that an axiom is independent, you produce a model in which that axiom is incorrect and the rest of the axioms are correct. So another way to replace each axiom with its negation and show the model for each negation. So example number 1, undefined terms natin ulit, point, line, on. Axiom 1, there exists exactly 4 points. Axiom 2, these two distinct points are on exactly one line, and each line is on exactly 2 points. So consider again the set of axioms previously stated. So ang interpretation natin ulit, points can be interpreted as letters A, B, C, D, or dots, while lines can be interpreted as columns of letters or segments. Okay, so recall negation. So axiom 1 natin, dito muna tayo sa axiom 1, there exists exactly 4 points. Ang negation natin, in-negate natin, there do not exist 4 points. So model for negated axiom 1. Since the model contains only 2 points, the negation of axiom 1 is clearly true. So meron lang tayong 2 points. Sabi ng axiom 1 natin, there exist exactly 4 points. So ninegate lang natin, we have only 2 points. Since we have only 2 points, then the negation of axiom 1 is clearly true. Dito tayo sa axiom 2. 2 distinct points are on exactly one line. So negation natin, there are no two distinct points on one line. Okay, so the model of negated axiom 2. Notice that in this model, there is no line on points AC. So ito yung mga columns of letters. So consider natin line tong mga to. Line connecting points A and B, lines connecting points C and D. So what are other pairs of points failed to be on the line? So wala tayong column for points A and C, point B and D, point AD, point BD. Next tayo sa model for axiom negated axiom 3. So sabi ng axiom 3 natin, each line is on exactly 2 points. Sabi ng negation natin, there are lines not on exactly 2 points. So ito yung mga points natin, we have 4 points, points A, B, C, and D. So dito naman tayo sa lines. So, yung lines natin is represented by columns of letters. So, sabi dyan, sa negation natin, there are lines not on exactly 2 points. For example, consider natin na line to. So, it is a line with points A, B, and C. So, ibig sabihin yan, na-prove na natin na tama yung negation natin kasi there are lines not on exactly 2 points. This is a line with 3 points. In this model, one line is on 3 points. So yan, points A, B, and C. Whereas the remaining lines are each on 2 points. Ito, yung column for point AD, point BD, point CD. So the negation of axiom 3 is true in this interpretation. So since we have demonstrated the independence of each of the given set of axioms, we have shown that this axiomatic system is independent. So let's proceed with the last property of axiomatic system. We have here completeness. So an axiomatic system is said to be complete if it is impossible to add an additional consistent and independent axiom without adding additional undefined terms. So proving the set of axioms as complete is quite challenging. The alternative approach is to show that the set of axioms is categorical. The axiomatic system is said to be categorical if the model of each axiom is isomorphic to every other model within the system. So, for you to better understand, dito tayo sa example. Example 1, let's consider the set of axioms. So, undefined terms ulit natin, point, line, on. So, pares tayo ng axioms 1, 2, and 3. So, i-model natin yung axiom 1. Model for axiom 1, undefined terms, points, lines, on. Interpretation for points, letters A, B, C, D. Lines, columns of letters given below. So, ito yung column for points AB, points AC, point AD, point BC, points BD, and points CD. On contains or is contained in. Model for axiom 2 naman natin. Okay, so yung points natin is interpreted by dots denoted by 1, 2, 3, 4 lines, segments. On, a dot is an endpoint of a segment or vice versa. Model for axiom number 3, undefined terms, points interpreted by dots denoted 1, 2, 3, 4. Lines interpreted by segments, and on, a segment contains dots. So ito yung figure 1 natin. Sabi ng axiom 2 natin, each line is on exactly 2 points. So itong line na to ulit is on 2 points, point 1, point 3. Itong line na to is has 2 points, points 3 and 4. This line contains points 2 and 3. This line contains points 1 and 2. Okay? So the axioms 1 and 2 have the same number of elements but interpreted in different way. So in axiom 1, points are interpreted as letters and lines are interpreted as columns of letters. While sa axioms 2 and 3 natin, points are interpreted as dots denoted by numbers and lines are interpreted as segments. So this implies that the interpretation letters in axiom 1 corresponds to the interpretation numbers in axiom 2 and axiom 3. So likewise, columns of letters correspond to segments. Since axiom 1 is congruent to axiom 2, axiom 1 is congruent to axiom 3, and axiom 2 is congruent to axiom 3, then the set of axioms is complete. So that's all for this morning. Goodbye, class.